Hello, we are in Unit 5, Section 1, and we are going to be studying populations and samples. So we're going to start out our notes here talking about who we want to study in some kind of survey and who we're going to actually talk to. Well, this is a complete shift of gears from what we've been doing. What we've been doing before has been a lot of more traditional algebra where we're dealing with x and trying to get it alone or trying to reduce things. And here we are jumping into a stats unit, which is completely different. So we are going to start out with the word population. And you might think of population as like, what's the population of Byron? Things like that. What we're going to be talking about with population is whoever you want to study. So who you want to study. So if I want to study Byron High School students, then my population is Byron High School students. The sample then is a smaller group than the population. Let's say your population's really big, like the United States. Your sample might only be 100 people from the United States. So who you collect data from. So we've got our sample and our population, and I always like to have a picture with that. So imagine your population, and inside that you have your sample. You think of the sample as just a little part of that population. So now we're going to go into some techniques that you could use to actually get a sample. So how do you get a sample that truly represents the population? One word we're going to write down is simple. It's actually a phrase, simple random sample. And sometimes we call this an SRS, simple random sample. So if you see simple random or SRS, it is talking about the most basic kind of random sample. Now the reason we want to use random is because if we don't choose our sample randomly, there's a good chance that we will pick it based on some reason, something that's going to make our results biased, meaning that our results will sway one way or another because of something that we think about or know ahead of time. So we want to avoid things like that, and so we want to do whatever we do randomly. So simple random, let's give a few ways of doing that, could be names in a hat. If you took every student in Byron High School and threw them into a hat and then randomly drew out names, that would be a simple random sample. Another way to do it would be to number every person. So imagine I ask you to find a list of all students in the high school and number them 1 to 550. So number everyone and generate random numbers. Now, when it comes to generating random numbers, there's a website called random.org. And so when you go to random.org, what it lets you do is generate random numbers between any two endpoints. So if we had a list of 100 people, we could generate from 1 to 100, and it will come up with a random number. Or if we had a random list from 1 to 550, it could do that too and generate random numbers in that range. And so random.org is a really good place to get random numbers if you don't want to cut out every single name and put them into a big bucket and draw them out. So let's continue on with more techniques that we know. So we have our simple random, but then there's also something called stratified random. Stratified. And what that means is that you break it into groups first and then choose randomly. So first, break into groups. Then, so after you first break into groups, then randomly choose a few from each group. And there are various ways to do this, some a little bit more complicated than others, but for our purposes we're just going to deal with groups that are the same size, so we're going to take the same number from each group. An example of this would be something like if you had Byron High School. So here's our high school. Let's say we're studying students. You could first break them up into 9th, 10th, and 11th and 12th grades. And then you could randomly pick a few people from each grade, so that when you end up getting your full sample, you have a good mix of the grades. That's the idea of stratified random sample. To compare that with simple random sample, we would just have the whole school in one big box and we would randomly generate numbers wherever they fell. So sometimes those kind of pictures might help, so you might want to draw those in. So we have simple random sample and stratified random sample. Next we're going to do systematic. Sample. So systematic means following a rule. And the most common one is to take every so many people. So let's say every however many people, such as every 10th person. This is typically used if you're standing outside, let's say, a door for a store, and you want to make sure that you get a balanced group. You don't want to just take the first 20 people that walk in the door. You want to spread it out throughout the day, but you don't want to be biased about it and just talk to people that want to talk to you. But you truly say every 10th person I'm going to ask them to speak with me, and if they say no, then go directly to the next one. So that's how you would do a systematic sample. If you were to draw a picture of that, it might look something like putting all the people in the school in order and then choosing a random starting point. That's important because it's not that if you didn't do that you would never pick the first person, right? Because if you count even by every 2 people, you would always skip the first person. But by starting at a random spot, you don't have that problem. So you'd end up with this regular spacing all the way through. And it might not look random, but if you start at a random spot, every single person has an equal chance of being picked. So it is, in fact, a perfectly random system. So we have simple, stratified, systematic, and now we're going to do cluster sample. And a cluster sample is where you take divide things into group, but you take the entire group. So take entire group. So an example of that would look something like if you took the school and divided it up into lunch tables, and then a cluster sample would say we're going to take this entire group, and you randomly choose the groups, but once you do it, you take the entire group. Now that has challenges because if these groups are not well mixed, let's say lunch tables, they're not random who you sit with. You sit with people that tend to be more similar to you. So by doing this, you end up getting some very biased results. You typically don't want to use a cluster sample unless you know your groups are randomly spread out. And then let's do one more example, and that's going to be a convenience sample. So add a little more room here. Last one is convenience sample. And that's really just a lazy sample. That means taking the easy way out. So an example would be asking your Facebook friends if you're doing an online survey, because they're easy to get to. Another one would be you're supposed to go out and ask people around Byron High School. Well, let's ask people that are in the room with me because that's easy. So convenient sample is all about not using those random techniques that we learned about above. It's about skipping straight to the answer, trying to just get data and say, oh, it's fine. This is going to lead to bad data. Or you could even use a big term for that, non-representative. And by that, we means that it does not represent the population that you want to study. If you are studying Byron High School students, this sample that you took, being a lazy sample, a convenient sample, will not represent the school well. So hopefully these will give you a good start to start practicing and recognizing these different types of sampling.